Assalamualaikum warahmatullahi wabarakatuh and a very good day I wish to everyone watching this. In this video, I am going to present about tutorial S15. Based on the question, first, investigate the role of optical instruments in optics. Explore how advancements in optics have limited the development of instruments such as the cameras, making access and users and microscopes. Second, discuss the principal behind these instruments, assessing how they manipulate light capture, enhance image resolution. Next, analyze the impacts of optical instruments on sales and diagnostics, astronomy and research. And lastly, consider challenges and opportunities presented by contemporary optical technologies, especially on potential future developments in the realm of optical imaging. Very panjang, is it? So, setelah saya renung-renungkan, actually the questions can be divided to a few smaller main points, which are the role of optical instruments, how does it help in development of sophisticated instruments, what are the principles behind them, how does it work, what are the impacts, challenges, opportunities, and potential future developments in these advancements. So let's go one by one. Firstly, optical instruments are devices that are used to measure and control the propagation of light. As we all know, or perhaps you guys have experienced yourself, the devices comes in various sizes and shapes and generally assist us in viewing and capture things or scenes we normally cannot do with naked eyes. They're generally subdivided to three parts consisting the lens, the light detector and the eyepiece in order to function. Apa kaitan instrumen ni dengan teknologi canggih yang kita ada nowadays? Menggunakan konsep general yang ada pada optical instruments dengan sedikit sebanyak upgrade. Sebagai contoh, here we have digital camera terdiri dari larger sensors, better noise reduction, high quality lenses and autofocus technology membantu fungsi penciptaan digital camera yang menghasilkan sharper and clearer image, ideal for low light and achieve exceptional sensitivity. Tu yang dapatlah kita capture gambar dalam gelap, gambar objek yang sedang bergerak laju dan sebagainya. Next, contohnya medical imaging devices seperti yang kita ada kat sini, which is MRI instrument. Dalam menghasilkan mesin besar ni, it has been applied with improved lens systems and light sources, optical fibers and better detector yang membolehkan kita obtain enhanced image quality and diagnose capabilities. Ada banyak lagi yang medical imaging devices seperti X-ray, ultrasounds, but this is one of it lah. And lastly, laser scanning microscopes is equipped with high energy and spatial resolution, high brilliance and monochromatically of laser light and better optics. And faster scanning membolehkan these laser scanning microscopes allows us to see detailed image at cellular and molecular level secara jelas. So, how does it work? Macam mana optik bekerja dalam these instruments? Untuk kamera, kita view through viewfinder. The aperture of the lens will be open with maximum width untuk membolehkan kita view image tu lebih cerah, even kita dah set small width for the aperture. And then the light coming from the lens will be reflected by reflex mirror to the pentaprism. The pentaprism then flips the image several times until finally the image can be seen in the viewfinder. At this point, the camera sensor does not receive light or an image because the shutter is still closed. When the button is pressed to take a picture, the aperture will be adjusted to the size of the opening that we have set previously. At the same time, the reflex mirror will be raised up to allow light to enter directly towards the back of the camera before the light is exposed to the sensor. Once the reflex mirror is raised, we can no longer see any image through the viewfinder. The shutter is open and the light will be exposed to the sensor to record the image. Next, untuk X-ray, optical pathway is applied starting from the X-ray tubes where the X-ray spectrum is emitted and provide continuous spectrum of radiation. And the X-ray optics applied with reflection and diffraction here and there, resulting with constructive and destructive interference tu yang menghasilkan image on the X-ray detectors. The first X-ray detector used was photographic film by using silver halide crystallites that will darken when exposed to X-ray radiation. So here I attach the link for you guys to check out for more detail. Lastly, laser scanning microscope. Contohnya a confocal laser scanning microscope. It works by passing a laser beam through a light source aperture, which is then focused by an objective lens into a small area on the surface of a sample. An image is built up pixel by pixel by collecting the emitted photons from the fluorophores in the sample. Moving on to the impact of optical advancements on various fields. For medical diagnostics, it has enabled non-invasive medical imaging techniques seperti MRI, CT scan yang we don't need to go further inside the patient's body to figure out what's problem. And by this way, it has improved the accuracy of diagnostics and it actually really helps in early detection. In astronomy, it has allowed the astronomers to capture and analyze light from essential objects using essential data and settle few problems regarding astronomy with the enhanced clarity of astronomical observations. Lastly, for optical remote sensing, different bands provided radiation values in different spectral bands, resulting in more specific and clarity of the ecosystem function. The challenges that we could observe is the challenge in achieving a higher optical quality, such as resolution limits. However, the advancements discovered today has solved the diffraction problems, but there are still ongoing research for even better and higher resolutions. The other challenges could be limited capabilities of current technologies to combine all essential imaging parameters together. The opportunities of these optical instruments could be a continued advancements in astronomy and other fields that leads to more researches, and perhaps kita boleh explore banyak lagi sebab bidang penglihatan dan pengetahuan kita sangatlah limited. Sekian itu sahaja dari saya. Terima kasih. 再见.